Greetings and welcome to a new calculus channel. My name is John Gabriel, and today I'm going to show you exactly what kind of monkey business that mainstream academics get up to. And of course it deals once again with my historic geometric theorem, which you see on the right here, and I'll explain that in a minute. So let's begin. The historic geometric theorem says that the slope of a non-parallel secant line, this line, okay, the slope of this line, yeah, is equal to the slope of the tangent line, which is this line here, okay, plus the difference between these two slopes, okay. So of course, naturally, 3, which is the slope of this line here, the non-parallel secant line, is equal to 2 plus 1. And so how does this work? How does this all work? And by the way, we know it's 3 because it's 3 this way and 1 this way, right? That's why that's 3. And this here is 2 because we've got 2 this way and 1 this way, right? Okay, so now the baboons of mainstream academia, who are incorrigible idiots called mathematics professors and teachers, love to do something like this. They decide they're going to let h vary and keep x constant, and so they take the limit of this, which is a constant, by the way. So they're actually taking the limit of 3, right? And they're saying it's equal to the limit of the tangent line slope plus the limit of the difference. So this is what happens. When we take the limit of this non-parallel secant line slope, it gets closer and closer to 2, right? Likewise, when we get closer and closer to 2, this difference becomes less and less, doesn't it? So what you're seeing is that the limit of these constants has a way of becoming a different constant. So let's see what happens here. So the limit of 3 is equal to 2, right? And the limit of 2 is equal to 2, and the limit of the difference 1 is equal to 0. So this here is always equal to 0, so no matter what the difference is, the limit of that constant is 0. Can you see what monkey business this is? Do you see now why I call mainstream math academics incorrigible morons? It's because they are people, and what they teach you is not only wrong, it's completely flawed, because limits have no place in calculus, not in differential calculus and not in integral calculus. In fact, limits are absolutely useless and unneeded in the only worthwhile applications of calculus, which are differential calculus and limits, and both the derivative and the integral can be defined using this identity, as I shall show you in an article which I'll place a link to in the details section. So without further ado, I'm going to stop here. My name is John Gabriel, and what I'd like to ask you to do is subscribe if you're not already a subscriber. Spread the news of my channel, and please feel free to contribute dollars and credits on my Odysee channel, to which I'll also place a link in the details section. And that's pretty much all I have to say for this video. Hopefully, I'll be in touch with you soon. This is a new calculus channel. Till next time, goodbye.